Live coverage of NASA's Phoenix mission to Mars from the Jet Propulsion Laboratory in Pasadena, California. After a tense few hours and a harrowing final 7 minutes to the surface, NASA has successfully landed a new spacecraft on Mars. The Mars Phoenix touched down about an hour and a half ago at 4:53 Pacific time. Hello, I'm Gayi Hill here at JPL Mission Control. Welcome back. The Phoenix team is now finishing a playback of pre-recorded data from entry, descent, and landing. The team is also looking forward to the first downlink of post-landing information that will be relayed by the Mars Odyssey orbiter. Let's go back into Mission Control right now with Robert Shotwell to get an update on the poll that took place at about 5:30, and we'll know a health and safety poll or status on the spacecraft right now. Let's go to Robert.
Just to recap what we saw here tonight, the EDL event looks like it couldn't have happened better than we planned it. The touchdown velocity, based on the information that we have at the time of touchdown, was less than 0.1 meters per second horizontal velocity, exactly 2.4 meters per second vertical velocity. That was the design value. The lander appears to have a tilt of about 0.3 degrees and is about 0.68 degrees rotation in azimuth about the nominal point. So almost exactly perfectly flat and aligned where we want it to. Initial estimates put the landing latitude at 68.22 degrees and 234.3 degrees longitude. The maximum rate seen on the chute was 34 degrees per second, which is about a third of what the worst case predicts were. At the time of touchdown, our batteries were still at 90% state of charge. We used 37.56 kilograms of propellant during the event, which leaves 16.9 kilos in the tank, which will freeze overnight tonight. The helium pressure was vented as expected, starting at about 4 seconds after touchdown. The parachute deployment occurred about 7 seconds long, or 7 seconds later than initial predicts, which led a little bit to the touchdown location being slightly off axis where we expected it to land, although all these informations are still basically temporary at this point until we get some more data after the next pass, which is due in about 12 minutes. We'll be able to update all of these values and get the precise ones for the record. Other than that, it was a nominal EDL event. Everything looked as good as we could possibly have expected. It almost looked dry labbed. And the EDL team has been thrilled with the results. We've now handed over to the surface mission, and the ops team is taking over from there in Tucson, and now hopefully they're going to make the best of what we just gave them.
All right, mission commentator Robert Shotwell, thanks for the update, Robert. With me right now is Peter Smith. He's the principal investigator of this mission, and you just have to be ecstatic, I'm sure.
Oh, I'm on Cloud 9, Mars Cloud 9.
Well, we have some of the highlights from landing, and we can roll the tape, and you can kind of talk about what it was like when you were in the room there. Let's roll the tape.
Is that the tape?
Meters. 150 meters. That's 100
well,
meters.
The first thing.
80 meters.
They're counting down the
50
altitude.
meters.
Jeez, somebody yelling.
Constant velocity phase detected. Altitude 40 meters. 30 meters.
Go ahead.
Well, I don't know what
meters.
point this is, so it's hard for me to comment.
Well, maybe I can help you out here.
50 meters, standing by for touchdown.
Richard Kornfeld, the EDL comm, and he's counting down the altitude as the spacecraft is coming
Touchdown
down.
signal detected.
Yes, this is the last. Yes, we were just the last 2 minutes we came down and touched.
Helium vent detected.
It couldn't have been better. Then we got signal that showed that we were still alive after 1 minute on the surface, and that our tilt was almost perfectly at 0, a quarter of a degree off. So,
standing by for normal termination of EDL comm.
It's a sort of a textbook classic scenario. You couldn't have ask for a better sort
Standing
of
by for nominal
situation?
termination.
No,
of
and
VDL
you know,
com.
we did a lot of testing of this in the past, and always something was going wrong in the tests. And
Absolutely.
This was just perfect, so it didn't seem real.
I was about to say that the mission does a lot of operation readiness tests where the whole team goes through the whole scenario over and over again. And I have to say that there were more problems during the tests than there were in the real thing.
Well, there sure were, and we had some very devious engineers controlling the tests, and they wanted to test us to make sure that we were ready for landing, so they would make little things go wrong. You'd lose communications, or there'd be a failure of one thing or another, and just right before going in, and nothing went wrong here. It was just absolutely perfect. That gives me so much confidence that our solar arrays have deployed and our cameras have taken pictures, and now I just can't wait to see that signal return to Earth.
Well, let's talk about what will be taking place. And we've got a couple of live cameras here. Now that we've landed on the surface of Mars, then it goes to surface operations, and you have a whole team in place in Arizona.
Yes. And they're already hard at work, as far as I can tell from the video from the operations center. They've been having meetings, and they're ready to go. So we just need to feed them some data.
So let's talk about the spacecraft. Now that we're on the surface, what takes place? The deployment of the various instruments. We've got the video for people to see.
Yeah, let's show that.
Okay.
So the first thing that happens after the deployment of the solar arrays and the camera is, well, over the first week we'll start taking scoops of the topsoil. And here's an animation of taking scoops of the topsoil. And now it's going to lift it up and place it inside of our TIGA instrument, which was built at the University of Arizona. And there it is being dumped into the instrument. And this is an oven that's inside of that little collecting device. And that oven allows you to heat up those materials and then find out what they're made of. And then we do a weather experiment. This is a LiDAR provided by our Canadian partners, and it's going to tell us about clouds. So over the next 3 months, we're going to analyze samples from the surface down to an ice layer, and we'll be using 3 different instruments on the deck, and we'll also be a weather station. So we do a lot.
Now, the way you operate this, the test bed, it will be at the University of Arizona, so you'll get information from the spacecraft, how it's situated, and then you recreate the whole situation here on Earth?
Yes, we're going to build as best we can the nearby features inside of our simulation laboratory.
And we have video of the lab.
Oh, do you?
The test bed.
Yeah, the test bed, absolutely. I'm not sure what this is. This is at Lockheed Martin, I think. Test bed I'm talking about is in Tucson.
And okay, so this is the Lockheed Martin.
Yes, this is testing of the cruise stage. You see the cruise arrays there, and there's our entry vehicle down below. So this is all the hardware that has now been jettisoned, so that we are now just a surface mission on the just a surface lander, which is just barely visible, sticking out the bottom of the back shell there.
I believe the latter part of this video does have the solar array deployed.
Well, there's our robotic arm, and there's the practice of delivering a sample to an instrument. I believe it's TIGA, if I'm not mistaken. And this is just to make sure that we know how to do it with our actual flight equipment. Now, what we've been doing since the launch is to practice with our simulated, or engineering models, if you like, in a simulated environment, and really delivering actual samples. You can't put dirt into the instruments on the flight model. Yeah, that's at Lockheed Martin.
So that is a critical step, am I correct, that one of the things that we're waiting for in this downlink is to find out